Hey, Julia,
Hi, Matthew.
what would you like to work on tonight?
I have a physics worksheet that I work on. I saw you a picture a few minutes ago. Yeah.
I see that now. Do you want do you want us to go through the projectile motion -1 worksheet first? Does that seem right?
Yes, please.
Okay, I'm snipping that first question in. Okay, let me share my screen and we'll get started here. Okay, so first question, could the human cannonball at the circus be considered a projectile while she flies through the air? So I guess my answer is yes. The setup here is your cannon is launching the person, the human, whatever, and they have this motion that they eventually come to back to the ground. I guess it maybe in your class notes they have some sort of like, these are the requirements for projectile motion.
Hmm.
If you have those, please take a look. I'm going to do a search here myself to see if there's something specific that it requires.
Okay. Wait, I'm sorry. What are we trying to find?
This is just a conceptual question. So it's asking can you consider the person flying through the air a projectile? And the only thing that I'm seeing that's needed for a projectile is acceleration due to gravity.
Mhm.
And essentially that's what causes this person to come back to the earth, because there's gravity. If there was no gravity, you just shoot off and never come back again.
Okay.
So again, this isn't my strength. Conceptual questions aren't my strength because I don't have all the right words, but I believe some combination of yes, acceleration due to gravity will be enough. Sometimes they have this issue of you have to treat the object as a point mass. Have you heard
Uh-huh.
of that in class?
No.
Okay, well, you can strike through that then. Oops. Is there any follow-up to that question? Otherwise, I'll move on to question 2.
I don't think so.
Yeah, okay, so again, kind of made this comment before, these questions are always slightly odd. Why isn't snipping in? Uh-oh. There we go. Let's see if I can get this to. Okay. So it's an airplane, drops a bomb and continues to fly straight ahead at constant velocity. Where will the bomb be in relation to the airplane when it hits the ground? So the idea is the airplane here, it's moving to the right. And at some
Hmm.
point here, we'll call this the point, it drops something. Now, it doesn't drop straight down. Like that's the misconception. It actually drops this way.
Hmm.
So in some amount of time, it does hit the ground. The airplane is continuing to move forward though this entire time. And
Right.
And what's maybe not clear is that the airplane is actually directly above the object. We'll talk about why. So the airplane drops a bomb and continues to fly straight ahead at constant velocity. This is key here, constant velocity. So the airplane, let's say the airplane is traveling at 400 kilometers per hour. That's probably really fast, but we'll just say that's okay. When the box is let go, the box is also traveling at 400 kilometers per hour.
Oh.
Okay, so it's kind of like this. When you're in the car, you're traveling at whatever speed the car is traveling at. But because you're traveling at the same speed as the car, that's why you don't feel it.
Okay.
Okay, is that okay? Is that clear?
Yes.
So the reason they're directly on top of each other is because they have the same, you want to say they have the same horizontal velocity. We moved to number 3 now. Is that okay?
Yeah.
All right. Sometimes I have no idea what's going on the other side. I'm sure you feel the same too. Like if I ever take a long pause. All right. Man throws a rock horizontally from the top of 75-meter cliff. Good. So it's a great picture. The rock leaves the man's hand at 3.25 meters per second. Determine the following. Okay. What is the following? I didn't catch all that. Oh, there it is. Time to impact. Okay. So I remember we worked on a problem a week ago or something, and they gave you time, and time is critical. Okay. If they don't give you time, you want to find time right away.
Okay.
So usually you find time from the y direction. Okay, so the equation in the y direction is y of t equals y naught plus v naught y t plus 1/2 a t squared. Have you seen that in class?
Yes.
Okay. So let's go through it variable by variable. The y naught, the initial height, is this 75. Okay, that's what it means by initial. What is your initial height? Your initial height is 75. The rock is thrown horizontally. So this is actually the initial velocity in the x direction. The initial velocity in the y direction is actually 0 because you're only throwing it straight to the right.
Oh, okay.
And the acceleration that's going down is due to gravity, which is minus 9.8. So this becomes plus 1/2 times minus 9.8 t squared. Y of t. So we'll simplify this slightly. It's 75 minus 4.9 t squared.
Okay.
All right, now what is the height when you hit the ground? 0.
0.
So now you just solve for t. Okay, so it's no longer a physics question. It's a math, algebra, pre-calculus, algebra 2, whatever you want to call it. You got to get t by itself. So you move 4.9 t squared over. It's 75. You divide by 4.9. And then you take the square root of that.
Okay, so that's the time it takes to travel, like to hit the ground.
That's right.
Okay.
That's T. And you like, I was trying to emphasize that like you always want to find T first. T is like the key to all the other stuff that you can do.
Yeah.
All right, so the next thing we're going to find is VFY at impact. And your instructor here is trying to help by saying they're using these subscripts to like try to explain what they want here. They want the final velocity, but only in the y direction at impact. It's not zero. A lot of times students they don't like they think, oh well, it must be, you know, you hit the ground, it must be zero. No, you jump, if you jump off a building or jump into a pool, like it hurts when you hit the water or the ground because your velocity is greater than zero. So or your speed's greater than zero, your velocity ends up being negative. So we can do this. The velocity at any time is the initial velocity plus acceleration times time. So your final velocity is your initial velocity plus acceleration times time. When we set up this problem, is the rock being thrown at all vertically, or is it only horizontal to start? It's only horizontal to start.
Mm-hmm.
So this V0 is 0. But the acceleration is G. It's minus 9.8. So your final velocity is minus 9.8. That's A times your T. What was your T?
3.91.
3.91. So T leads you to the path of being able to find these other values. Now I am awful at this, but you do have to use units. Very, very important in this class.
Mm-hmm.
Is that okay? Is that clear?
Yeah, that makes sense.
Okay, so the horizontal distance traveled, that's the next or the last thing here on this page. The horizontal distance traveled okay, that is so that's it's the same as the y equation, but you write x. You say x of t equals x naught plus v0 in the x direction is times t plus 1/2 a t squared.
Okay.
So your x0 is actually 0, like you're starting at the top of a cliff, but your x value is 0 there. So that's 0. Your V0, that's the one that's given. That was the 3.25 meters per second. Now this is quite standard. The acceleration in the x direction is almost always 0. The acceleration is always in the y direction, which is g. It's 9.8. But we're interested in the x direction horizontally. That's why the acceleration is considered to be 0.
Mm-hmm.
So the distance it travels here is the velocity times the time, 3.91.
Okay.
So you get 12.7 meters. Anything else you would like us to cover on this page? Anything that was unclear about any of these questions?
I think I'm good.
Okay. Let me try to just be clear here that if you'll allow me, we could just jump right to the next questions, but I think we have plenty of time here to finish them. There's equations there's equations for distance, velocity, and we'll leave it at that. And they're in both the x direction and then in the y direction.
Okay.
And you're going to see that they're actually very much the same. Like they're not very much different, but we use kind of different notations. So in the x direction, it's x0 plus v0 xt plus 1/2 at squared. Okay. But very often, and I'll just put this in the corner here, a equals 0 in the x direction.
Okay.
In the y direction, it's the same equation. We just use y instead of x.
Mhm.
But this time, a is almost always minus 9.8.
Oh, okay.
So that's the big difference here. The velocity in the x direction, the velocity is always the initial velocity plus acceleration times time. But again, this kind of still holds. A x is always 0. Like this is usually 0. And similarly here, y of t equals, I'm sorry, we're doing v now. V of t equals v0 plus acceleration times t. But again, like it's very often that it's minus 9.8.
Okay.
So like if this isn't clear, like you get it later or write it down, but like there's really only two equations, but it's just like one's in the x direction, one's in the y direction. One, certain things are true, and other certain things are true.
Mhm.
Okay, so we'll move on to projectile motion 2. And by the way, most physics classes start with this, not like in the first semester. So whatever. It was just strange. We were doing some of that other stuff last semester where it was Kepler's laws and things like that. But
Oh, okay.
this is usually where most students start. Okay, another sort of weird scenario. Bomber flying towards a school at an altitude, accidentally drops a 1,000-pound bomb. I can't believe this is given, but okay. So the plane's here, and here's Earth, and here's the school. Nobody's in it though. So they drop it, right? And we know that it follows this motion. So we don't know whether it hits here, whether it hits here or other.
Okay.
Is kind of the scenario set up kind of clear?
Yeah, that makes sense.
The height is 325. The velocity, which is only in the x direction, is 115. And the distance away from the school is 1,275 meters. Is that okay? Kind of clear? You got to do a picture every time you set up a problem like this, just to kind of get an idea of what's happening. All right, so the first thing we need to find is time. I know it tells you to find time, I think. Let me scroll down and look. Yeah, so you always find time, and time comes from the y direction. So y of t equals y naught plus v0 yt plus 1/2 at squared. Okay, so we know some of these values. The first value is that it's flying at 325 meters.
Mhm.
Is there an initial velocity in the y direction? There is one in the x. It's flying straight to the right. Is there an initial velocity in the y direction?
No.
No. The acceleration is due to gravity, minus 9.8. So that's plus 1/2 minus 9.8 t squared. What is the height when it hits the ground? It's not the distance. What's the height, the vertical height?
325.
That's the horizontal distance. We want the vertical.
Oh.
The height is 0 when it hits the ground. We consider our origin right here, right there. Okay, so it's really no different than the setup on the previous problem. Can you solve this for t for me, please? Let me know when you get a time for this.
Okay. Um, 56.4791.
Did you take a square root of both sides?
Yes.
Okay, so let's take a look at this together. So you're going to add 4.9 t squared to both sides equals 325. You're going to divide both sides by 4.9. So t squared equals 325 over 4.9. And then you're going to take the square root of both sides. Is that right? Yes.
Yeah.
So you should get t equals 8.14 seconds.
Okay, that makes more sense.
All right, so t unlocks all the other information that we're looking for this problem. So that's why it's so important to get time first. Even if it doesn't ask for time, you should find it anyway. Okay, so let's actually do the horizontal distance that it travels. I know it's a little bit different order than we did last time. I'm just going to snip that right here. So the horizontal distance, we have that equation. It's x of t equals x naught plus v naught xt plus 1/2 a t squared. But in the x direction, horizontally in the x direction, it's always 0. So this last term goes to 0. And often you're starting at 0. Like we consider where you started to be 0. So
Okay.
so the short of it is that the distance it travels, it's its velocity times time. And its velocity was given as 115 meters per second times 8.14 seconds.
Okay.
Okay, let's calculate that. 115 times 8.14, 936 meters. Okay, now if we go back to our picture, the school is 1,275 meters away. So it's more like this first picture, this first drop here. Do you see that? Because it doesn't quite. Juliet, is that clear? Does that make sense?
Oh yeah. Uh-huh.
Okay, sorry. So I think that's even asked. I think it says, do we get hit? And the answer is no, because it hits before.
Okay.
Now you could say to your instructor like, hey, it might hit, and vibrations affect the school or something like that. But they're that's what they're asking for. So the next thing on this list is V final Y at impact. V final Y at impact. So the Y direction velocity, do you have that?
The Y directional velocity.
The final Y velocity. So Vy is equal to V initial plus acceleration times time.
Okay.
Okay, so for example, or in this problem here, what was the initial velocity in the Y direction? It was 0, because it was only in the X direction that was moving. It was 115, but Vy was 0 because it's only moving to the right.
Mm-hmm.
So this is actually 0. The
Okay.
acceleration in the Y direction, that's gravity. That's minus 9.8. And then the T was 8.14 seconds.
Okay.
It's okay that the velocity is negative. In fact, it makes sense that it's negative because it's moving down. And we associate down with negative. So it's minus 79.8. Oops, why did I write that? 79.8 meters per second.
Okay.
Is there anything you want us to cover again on that question? That covers everything.
I'm confused on how to identify the horizontal velocity.
So if we go back to the initial question, the airplane was flying at a velocity of 115 meters per second. You have been on a plane before, like it just stays the same. You just go. It's like when you're driving now, I believe you told me that, like you like when you get on the interstate, you set your cruise control, or if you get, going down a road and there's not much traffic, you just stay at the same speed. You don't change speed.
Mm-hmm.
So that's what it means by its velocity, and it's horizontal. Like it could, you've been on an airplane, like sometimes airplanes go up, they go down, or if you kick a ball, and that's kind of what the next question is asking about. It's like to make something go up, you have to give it upward velocity.
Mm-hmm.
But that could vary, right? You could really go any direction. And if it had velocity straight up, it's going to go straight up and down and not anywhere out to the right.
Okay.
So 2 kind of addresses your question that you just asked me.
Okay.
The most problems you're going to see and this is where the difficulty, kind of increases in your class. It has both it has both an X and a Y component. Okay, so I'm going to all right. So so what they're saying here is it's here's ground, and this is 40 degrees, and it's going at 60 meters per second.
Okay.
So there's this like, I don't know what It's vectors. You see it in advanced math classes, but they kind of hide it from you here. To get this up and to the right, there's a right component and then an up component. And then there's the 60 component. And these make a right triangle.
Mm-hmm.
Okay, so you took, or you've taken geometry. I don't know if you've done any trigonometry in your class right now. But if you wanted this side of the triangle, which we're going to call y, and this side, which we're going to call x, we can use some combination of sine, cosine, tangent to do that. Now that'll make more sense in a moment. So the cosine of 40 is the adjacent leg over the hypotenuse. It's the adjacent over the hypotenuse. Do you remember that?
Yes.
So if you solve for x, you solve for x by cross multiplying here. So 60 cosine 40 equals x. You see that? You just multiply diagonally.
Mm-hmm.
Okay. So grab your calculator and make sure your mode is in degrees.
Okay.
And let me know what you get for that.
45.96.
It's basically 46.
Okay.
Okay, so in the x direction, the velocity is 46 meters per second.
Okay.
So we're going to move on to the y direction. So which trig function do you think we should use for the y?
I don't remember.
Okay, so we're going to try sine. Okay, so the sine, and I'm going to write this down in just a moment here. I was just going to see if you could pick it up here. So the sine of 40 degrees equals y over 60.
Okay.
So again, in this case, it's 60 sine 40 equals y. So you're going to grab your calculator and work this out similarly. I mean, it's just sine instead of cosine.
38.56.
Yeah, great. So what this is saying is that like it's going 60 up and to the right, but it's got these individual components that make up that 46 and then the 38.6.
Mm-hmm.
So there's kind of a shortcut here. And that's, I think, like what your instructor will show you here is that let's say they give you the velocity. Okay, and they give you the velocity and they give you the angle. The
Mm-hmm.
velocity in the x direction is the velocity they give you cosine of that angle, which is usually theta. And the velocity in the y direction is that velocity sine of theta. These are like the shortcut formulas that you often see.
Okay.
So really quickly, if you don't mind, just going to switch screens for a moment here. When I had messaged you earlier, what I'm doing on Instagram is some students are sometimes sending me questions and I'm answering them with short videos or just write-ups. It's completely confidential. It's totally up to you if you want to do it. But if it's really short, like if it's like literally like one question and you think it could be answered in like a minute or less, I'd be happy to do it here and just trying to grow my social media presence if you want to do that. But all right. We have a little time left. If there's anything else you'd like to cover tonight.
I don't think so. I think I'm good.
Excellent. So I'll send you the notes out shortly, and that screen recording will upload in about 12 to 24 hours. Thanks so much for booking, and I'll see you next time.
Okay, thank you.
Have a great
Bye.
night. Bye now.